Welcome, Lukas Tallund from Volumental.
Hey everybody, I'm Lukas and I work at Volumental. About me, I'm by heart a software engineer, which kind of got thrown into the hardware space. When I started at Volumental, we didn't really have anybody that knew anything about hardware, and we realized quite fast that we needed hardware. So that's where it's at. This also includes me flying forward and back to Shenzhen quite often, and therefore I got back yesterday, and I'm on Shenzhen time zone. So right now it's like 1 o'clock in the night. So if I'm speaking slowly or fast or anything, just tell me. Oh, okay. About Volumental. Volumental is a 3D scanning startup. We're focused on feet scanning at the moment. And next to me here on the stage is our scanner. Most people cannot probably see it, but I might do a demo later downstairs during the break. Anyhow, Volumental does 3D scanning, and for end consumers, the end consumer can come to a store and scan their feet, and for the consumer, they can then get shoe recommendations. So our scanner makes a 3D map of their feet and suggests which size a person should buy of that specific shoe. Or if the person wants a specific style, it can suggest which model in this style. For the retail stores, this gives the ability to sell shoes online without having the end consumer worry about if the shoe fits or not. And for a brand, for example, New Balance, it gives statistics on how their user base, how their feet look, which they can use in research and development for future shoe models. And all of these are very valuable data streams for all of the included parties. So seemingly our product is quite successful at the moment. But first, before I get into the talk, a disclaimer. As you heard, I'm a software engineer, and Volumental is also a software company, which means that this might be from a slightly different perspective than what is usually presented here at Stockholm Hardware Space. Anyhow, in the software business, there have been quite a lot of fuss over deep learning and data is the new oil, and other headlines have been blooming about in the software industry for quite some while now. But if you actually take a look at these topics, it's in quite limited areas where these technologies are successful. It's often these areas are, for example, commercials from your browsing data, or actually asking people for input, like what do you like, and then you can use that data. So it's quite a limited subject at the moment, and the reason for this is because these algorithms require quite a lot of data to be accurate and actually function, and it's really, really hard to collect data. So to collect these kind of data streams, which are not tied directly to your smartphone or to your computer, we kind of need some kind of hardware channel where we can access the data. And of course, the data is always there. The question is, how do we collect it? And from Volumental's perspective, this turned out to be really, really hard. Because we're a company of software engineers, which are very successful in what they do, but we had 3D reconstruction capabilities, but we need data that we can feed into the algorithms. And we were looking at different solutions, and as a software company, the smartphone is of course the perfect sensor. It has a camera, and it has IMUs and other things which are very, very useful for collecting data. But sadly, it's very hard to create a good user experience with a smartphone. And quite a lot of times, the capture fails, and the end consumer will never try to use our app again. So actually finding something that we can collect data with, which have an easy user experience, which people want to use, and which gives us data which are actually useful for improving our algorithms, turned out to be very, very important. And after some tinkering about, we understood that we actually needed our own dedicated hardware for this. And therefore we developed the scanner, which we have here. It's titled the Volumental Scanner, and it consists of 4 depth cameras, static depth cameras, and some computational units and so on. And this is what I would consider the trend of my talk, that building hardware that is specialized on collecting a certain data stream is turning out to be very, very successful in many areas. Because having generalized hardware to collect data, it requires the person that is collecting the data to want to collect the data. But having customized hardware enable you to collect the data without any real user input. So some examples of this. One very successful company that started with this in, I think it was 2010, is Walkbase. They do in-store browsing tracking. So you walk around in a store, and they track you by using your cell phone as a beacon. And then they have sensors all over the store, and they can give you a heat map, or they give the store a heat map of where their customers are going, so that the store can optimize their layout. And this is an example where customized hardware actually captured a data stream which were not used at all before. Another example of this is where we had ways of collecting data in a similar fashion as maybe Volumental, but it was cumbersome and it was quite slow to collect the data. Is all of these home assistants which Google and Amazon and so on released during the last year. These consist of microphones, and they listen for they listen for speech, which are then used for natural language synthesization. So helping Google improve their language understanding and also language talkback, so the consumer products can talk back to you. A third example of this, of very customized hardware, is habit tracking. And similarly to all of these bracelets where you have heartbeat tracking and so on, one of those, a small spin-off of those, is a company called Habitware, where they use the IMU data to see if you, for example, bite your nails, and then they warn you that this is something that you shouldn't do. And all of these captures data early in the stream without any real user input, which are otherwise data streams that would be lost. Okay, that was everything for me.